This is the acid-base question from the November 2015 exam paper. It is quite a difficult acid-base question, so I'm going to go through the answer step by step. 7.1. Ammonium chloride crystals dissolve in water to form ammonium and chloride ions. The ammonium ions react with water according to the balanced equation below. So ammonium ions react with water to form ammonia, which is a weak base. You guys must just know that. That's a weak base. And hydronium ions form, and that is a strong, very strong acid. Strong acids form high concentrations of hydronium ions. So a weak base and a strong acid is going to give you an acidic solution. Write down the name of the process described by the underlined sentence. The ammonium ions react with water. This process is hydrolysis. The definition of hydrolysis is it is the reaction of a salt with water. So the answer there is hydrolysis. 7.1.2, is ammonium chloride acidic or basic in an aqueous solution? Give a reason for your answer. It is acidic. Ammonium chloride solution is acidic. During hydrolysis, the ammonium ions react with the water to form a weak base and a strong acid that makes the solution acidic. The chloride ions do not undergo hydrolysis. I've done a video on hydrolysis of salts, and there I said that the ions from group 1, group 2, group 7, chloride ions are from group 7. They do not undergo hydrolysis. And also nitrate ions and sulfate ions do not undergo hydrolysis. So the chloride ions do not react with the water. 7.2. A certain fertilizer consists of 92% ammonium chloride, a sample of mass X grams, so that is the mass of your total sample, of this fertilizer is dissolved in 100 centimeters cubed of a 0.1 mole per decimeter cubed sodium hydroxide solution. So the ammonium chloride fertilizer, which is only 92% ammonium chloride, is dissolved in 100 centimeters cubed of a 0.1 mole per decimeter cubed sodium hydroxide solution. The sodium hydroxide is in excess. You guys in grade 12 do not need to know this reaction, therefore they gave it to you. So here's your ammonium chloride, that is 92% of the fertilizer. The other 8% would be sand or limestone or other fillers. So the ammonium chloride in the fertilizer reacts with the sodium hydroxide to form ammonia, water, and sodium chloride. When they give you a reaction, write in all the information that you can. They tell you that the sodium hydroxide is in excess. So I'm going to write that in there. So we know that the ammonium chloride is all going to react. The sodium hydroxide solution, we have 100 centimeters cubed of it. So I'm going to put that in. And we also have the concentration, 0.1 mole per decimeter cubed. When they give you a volume and a concentration, you can calculate the number of moles according to this equation. Number of moles is concentration times volume. Remember, your volume must be in decimeters cubed because concentration is in moles per decimeter cube. So I can find the total moles of sodium hydroxide that I started off with. Remember, it's in excess, so not all of it will react in this reaction, but all of the ammonium chloride is going to react. So I'm going to write here limiting. This is your limiting reagent. Sodium hydroxide is in excess. Calculate the number of moles of sodium hydroxide in which the sample is dissolved. So that is your first question, 7.2.1. We're going to find the number of moles of sodium hydroxide. Always show which substance you are working with. I'm working with the sodium hydroxide, so you can either subscript in with sodium hydroxide, I just put it in the brackets. So the concentration is 0.1. Remember, the volume must be in decimeters cubed, so your total number of moles of sodium hydroxide is 0.01 moles. If you just write N is equal to C times V, then write at the end of this answer so many moles of sodium hydroxide. There must never be any doubt for the marking person which substance you are working with. Now we carry on to the next section. During the titration, 25 centimeters cubed of the excess sodium hydroxide solution. So the sodium hydroxide solution that did not react in this reaction. Remember, it's in excess. Some of it reacts with ammonium chloride. So they are taking 25 centimeters cubed of the excess that didn't react. So during a titration, 25 centimeters cubed of the excess sodium hydroxide solution is titrated with a 0.11 mole per decimeter cubed hydrochloric acid solution. At the end point, so this is neutralization. At the end point, it is found that 14.55 centimeters cubed of the hydrochloric acid was used to neutralize, important, the sodium hydroxide solution according to the following balanced equation. So this is a neutralization reaction. It is important to notice whether a reaction is neutralized or the endpoint is reached, or whether we have a situation like this first reaction where something is in excess. So they've given us the concentration of the hydrochloric acid, 0.11 moles per decimeter cubed. And they also gave us the volume of the hydrochloric acid, 14.55 centimeters cubed was used. Again, they gave us volume and concentration, so we can find the moles of hydrochloric acid that reacted here. The question is, calculate the mass in grams of the fertilizer used. So it's the total mass in grams. The total mass, not just the mass of the ammonium chloride, it's the total mass that they want. We are first going to find the mass of the ammonium chloride, and from that we will calculate the total mass of the X grams. So I'm going to find the number of moles of hydrochloric acid using the same equation that we used in 721. So the number of moles of hydrochloric acid that reacted in the second reaction, concentration was 0.11, and the volume must be in decimeters cubed. The answer is 0.0016 moles of hydrochloric acid. So these are the moles of hydrochloric acid that reacted. The ratio of hydrochloric acid to sodium hydroxide is 1:1. So therefore, in your second reaction, the number of moles of sodium hydroxide that reacted is also 0.016 moles. But this is the number of moles of sodium hydroxide in 25 centimeters cubed. In 25 centimeters cubed, because they said during a titration, 25 centimeters cubed of the excess sodium hydroxide solution. But remember, we started off with 100 centimeters cubed of sodium hydroxide. So I want to know how many moles of sodium hydroxide were in excess in the 100 centimeters cubed. So 25 centimeters cubed is a quarter of 100. So I'm going to multiply these moles with 4 to get the total number of moles in excess in the 100 centimeters cubed. So I'm just going to write here in 100 centimeters cubed. The number of moles of sodium hydroxide that were in excess in 25 centimeters cubed was this amount, 0.0016 moles. But we used 100 centimeters cubed of sodium hydroxide according to this paragraph over here. So the excess moles of sodium hydroxide in 100 centimeters cubed will be 0.0064 moles. We started off with a total number of moles initially of 0.01. So we had 0.01 moles of sodium hydroxide here. We have worked out that the unreacted moles, the excess moles, is 0.0064. So the moles of sodium hydroxide that reacted in the first reaction with the ammonium chloride, so I'm going to write, we're going to calculate that now. The number of moles of sodium hydroxide that reacted with ammonium chloride in your fertilizer is equal to the total that we started with minus whatever was unreacted. And that is going to give us 0,00, I'm going to give the whole answer, 0,003598 moles. These are the moles of sodium hydroxide that reacted with the ammonium chloride. We have our reaction ratio. 1 mole of ammonium chloride reacted with 1 mole of sodium hydroxide. So I'm going to carry on working over here. So the number of moles of ammonium chloride that reacted in the first reaction is going to be 0,003598 moles. Okay, this has got nothing to do with 7.3, so we're just carrying on up there. Okay, so we've got the number of moles of ammonium chloride that reacted. When you have the moles and we are working with mass, you can actually calculate the mass of ammonium chloride that reacted. Mass is number of moles times molar mass. So it's 0,003598. The molar mass of ammonium chloride is 53,5. So the mass of ammonium chloride that actually reacted was 0,192 grams. But remember, it says a certain fertilizer consists of 92% ammonium chloride. A sample of mass X grams of this fertilizer was dissolved in the sodium hydroxide solution. The question in 722 is calculate the mass. So they want 100%. This is 92%. So the mass X, we want 100%. So it's going to be 100 over 92 times 0,192 grams. This is 92%. I want 100%. So this gives me a total mass of 0,209 grams. So X is 0,29 grams. That is the answer for 722. Now 7.3, I'm going to answer it down here. 7.3, calculate the pH of a 0,5 mole per decimeter cubed sodium hydroxide solution. Sodium hydroxide, you guys should know by now, is a very strong base. It's a metal from group 1 with a hydroxide. So it's a sodium ion bonded to a hydroxide ion. It's an ionic substance. It's a base. So when it dissociates in water, remember bases dissociate in water except for ammonia, which ionizes in water. It's going to break up into a sodium ion and a hydroxide ion. So for every particle of sodium hydroxide, you will form one hydroxide ion. So your hydroxide ion concentration is going to equal your sodium hydroxide concentration. They gave you the concentration is 0,5 mole per decimeter cubed. So I know the hydroxide ion concentration. There are two ways to calculate the pH of a base. I'm going to do the one option first. We have the ionization constant of water. You have this equation on your data sheet, which gives you the hydronium ion concentration times the hydroxide ion concentration equals the ionization constant of water, Kw. We've got the hydroxide ion concentration, 0,5. I want the hydronium ion concentration because that goes into your pH equation. So hydronium ion concentration in this case is going to be equal to 2 times 10 to the negative 14. We substitute that into our log equation. pH is negative log. Give all the equations, please. pH is negative log of your hydronium ion concentration. So that's negative log of 2 times 10 to the negative 14. So we get a pH of 13,698, so I'm going to make it 13,7. So this is option 1. Whenever you work with a base, you find your hydroxide ion concentration, substitute it into this equation to get your hydronium ion concentration. Once you have the hydronium ion concentration, you substitute it into the pH, which is equal to negative log of the hydronium ion concentration. The other option, you find the pOH of your base, that's equal to negative log of your hydroxide ion concentration. Once we have this answer, we're going to subtract it from 14 to get the pH. So that's equal to negative log. The hydroxide ion concentration was 0,5. And this is going to give us a value of 3. Okay, so your pOH value is 0,3. They asked for pH. You just subtract the pOH from 14 and your answer is 13,7, which is exactly what we got in option 1. So you can use either of these two methods. Use the one that your teacher prefers.